All right, so this last time we're going to go 2 pi, but we're going to go the other direction. We're going to go clockwise, so we're going to subtract 2 pi, which makes this the cosine of 2.3 minus 6.28. And when I do that subtraction, I get the cosine of negative 3.98. All right, now each of these might not have a perfect cosine of negative 0.67 because, of course, we're using estimates here for 2 pi, 4 pi, and minus 2 pi. But I want to show you on the calculator how this actually works. All right, the first thing I want to do is make sure that I'm in radians, and I am. Good. And cosine of 2.3. Okay. Now I want to show you cosine of 2.3. Now, rather than putting in 6.28, I'm going to put in exactly 2 pi. And see how I get the exact same thing. Now let's do cosine of 2.3. I'm going to put in exactly 4 pi. And I keep getting the exact same thing. And then cosine of 2.3 minus 2 pi. Because all I'm doing is going the other direction and going all the way around the circle. So I should get the exact same thing. Now when I use my estimate and I do cosine of 2.3 and I use an estimate for 2 pi like 6.28, it's not going to be as perfect. It's a little off from what we got for the other answers. And that's to be expected. Because we're using an estimate, we're going to get an answer that's not exact. Okay, number 10 asks us to give 3 solutions to this equation. Tangent of theta equals 4. Well, since I know that the tangent of theta is 4, if I want to find theta, I have to get rid of the word tangent. I want to just say, what is theta? So to get rid of the word tangent, I need to take the inverse tangent of each side. And tangent and inverse tangent cancel, and I'm just left with theta is the inverse tangent of 4. And I will go ahead and put this in my calculator and get an answer for tangent. And for theta, I put inverse tangent of 4. And I get theta is 1.326. Now that's because right now my calculator is still in radians. If I want to have 2 other solutions, theta could be 1.326 plus, I could just add pi. Because with tangent, I don't have to add 2 pi, I can simply add pi. A third answer would be 1.326 plus 2 pi. I could keep going and say 1.326 plus 3 pi and just keep adding over and over and over again. If I want it to be exact, I should probably leave it as plus pi rather than adding 1.326 and 3.14. But if I did do that and I wanted an estimate for that, let me see, what is 1.326? Plus 3.14, I get approximately 4.466. So I did that on my calculator there. All right, I could also do 1.326 plus 6.28, and I get 7.606. Or 1.326 plus, I don't know, 3 pi off the top of my head, so I'll just do it like that. And I get approximately 10.751. So those are all of my answers. I actually have 4. I know they only asked for 3, but that's 4. Now, if I want to do my theta in degrees, and then I would need to go on my calculator to mode and go over to degrees. And now I can do inverse tangent of 4, and I get approximately 76 degrees. So theta equals 76 degrees. If I want other answers, theta could be 76 degrees plus halfway around the circle is just 180. So I would take 76 plus 180, and I get 256. I could go all the way around the circle, 76 plus 360, and I get 436. I could add another 180 to that. And I get 616. So that was 316, 180, that was 540. And I got 616. So I just kept adding 180. I could just keep adding 180 and get more and more angles if I wanted to. Okay. Now I'm going to do just this one lesson master with you guys just before 5, and then I'll let you do the other lesson masters on your own. So let's look here. Number 1, sine of 11 pi over 4. So I need to figure out where 11 pi over 4 would be. So I'm a visual learner, so I like to look at a picture of a unit circle. Pi over 2, this is pi, 2 pi. And I know that my pi over 4s are here. And then I have my pi over 6s, and my pi over 3s. Alright, so 11 pi over 4. 11 divided by 3 gives, 11 divided by 4 gives me, not quite 3, it gives me 2 3/4 pi. Well, 2 pi is right here. And then, so this is where 2 pi would be. So 11 divided by 4 is 2 3/4. 2 is right here. 3/4 is right here. And my sine is my y coordinate. But remember, in my pi over 4 family, my x and my y are both square root of 2 over 2. And because it's sine, that's the y coordinate, it's positive. So what I did here was I actually just found the sine of 3/4 pi. That's what I did to get that answer. Negative 8/3. Let's think about that. 8 divided by 3 is 2 2/3, but it's negative. So it's going to be negative 2/3, which would be right here, because this would be negative 1/3, this is negative 2/3. And so right there, I'm finding the cosine of, this is in my pi over 3 family, which is across from my pi, this is pi over 3, so this would be 4 pi over 3. And my cosine of 4 pi over 3, that's my x coordinate. And my x coordinate there is a half. And cosine is negative. Sine of 25 pi over 6, 25 divided by 6 is 4. 4 pi would be right here. And 1/6, that would be right there at pi over 6. So sine of pi over 6. The y coordinate, which is 1/2. Negative 585. So if I go all the way around the circle, I am at negative 360. So I've got to figure out where negative 585 is. So what I am going to do is I'm going to think of 585 minus 360, which is a full rotation. And I'm left with 225. So I went all the way around 360, and then I'm going to go another negative 225, because this is negative. So 225 would be right here, which is the cosine of positive 135. That's what's on my unit circle right here, is positive 135. And what is the cosine there? Well, both sine and cosine, all my pi over 4s, are square root of 2 over 2. And it's the x-coordinate, so it is negative 9,900. Okay, let's see how many 360s go into 9,900. So I'm going to do on my calculator 9,900 divided by 360. I get 27.5 revolutions. So 27. Even though it doesn't matter that it's an odd number, that's because I divided by 360, that's 27 full revolutions, and then another half of a revolution, halfway around the circle, that's 180. So I'm finding the sine of 180 degrees. 180 degrees is right here. That ordered pair is negative 1, 0. Sine is the y-coordinate, so it's 0. All right, cosine of 405. I know that when I'm at 405 and I subtract 360, I would be left with, let's see, that'd be 45 degrees. So I'm going to go all the way around the circle and then go another 45 degrees. So I'm finding the cosine of 45 degrees. Everything in quadrant 1 is positive. And sine and cosine of 45 is square root of 2 over 2. So what you're having to do is determine where on the unit circle each one of these would be. And it's going to take you some time to figure that out. It's not something that's just you can just do real fast. So please take your time as you try to work through figuring out where on the unit circle is this going to be. All right, now we're going to just review some of the basics of the unit circle. My sine curve. So what I'd want to do is maybe go back and look at my sine curve. And my sine curve was this one right here, at the bottom. I can also look at the table that I filled out for sine, which was this table right here in my notes, and this is going to help me as well. So as I think through this, let me get back to that page. The domain, which are x values, are all reals because that sine curve just keeps going like this forever and ever. Right? The range goes from -1 to 1. It never goes above 1 and below -1. The zeros sign when I look at my graph. So I'm going to go back to my graph and look at it. My x-intercepts. It crosses at -2 pi, -1 pi, 0, 1 pi, 2 pi. Then it will cross at 3 pi, 4 pi. So all of my integer values, or integer multiples, I should say, integer multiples of pi. The period, sine repeats every 2 pi. Even, odd, or neither. Let's look at the graph. That wasn't something that we answered in our table, but we can determine that. Is this reflection symmetric over the y-axis or rotation symmetric around the origin? When I look at this, in order for it to be symmetric, it would be rotation symmetric around the origin, which would mean that this is odd. So I'm going to, sorry, I'm on the wrong page here. That is odd because it's rotation symmetric about the origin.